Day 3, Problem 1. A diagonal is drawn in a cube from corner to opposite corner. In this drawing, that's this segment right here from the back top corner and then coming through the middle of the cube and touching now at the front bottom corner of the cube. Use the Pythagorean theorem twice to find the diagonal x. Okay. So here we have a drawing of a cube, and it looks like that all of the edges of the cube are 4 centimeters, and we're asked to find how long is this diagonal segment. Now the hint provided to us is that we need to use the Pythagorean theorem twice. And the reason for that is, if we're going to find the length of this segment, we're first going to have to find the length of this segment here, which is drawn dashed. Okay. The reason for that is that we want to consider the triangle that we can see drawn in this cube. I'm highlighting that in red. And then here, that triangle highlighted in red is a right triangle. Now from our point of view, it doesn't look like a right triangle, but if you consider what it would be with a real-life cube, then the back edge coming down would be touching the bottom surface at a 90-degree angle. And so that triangle is a right triangle. It's just when it's drawn to make it look three-dimensional, it's not actually drawn as a right triangle. Okay? And so because it's a right triangle, we could find the length of this side, which would be its hypotenuse, if we knew the length of this leg and this leg. Well, we do know the length of this side is 4, but we do not know the length here. And that's why the hint is to use the Pythagorean theorem twice, because there is another triangle in here made by this side and this side and then that side that was dashed, and that is also a right triangle. Again, it doesn't necessarily look like it the way it's drawn on paper, but if you consider a real-life cube, then this edge of a cube, when touching this front edge, forms a 90-degree angle. And so this is a right triangle. And we know that this leg is 4, that this leg is 4, and that this side of the triangle, which is its hypotenuse, is the one that's missing. Okay? So let's find the length of this side here, which was dashed. I'm going to put the letter C on it because it is the hypotenuse of this right triangle. Okay? So now the Pythagorean theorem, a squared plus b squared equals c squared. A and b are the legs of that triangle, 4 and 4. Four squared is 16. 4 squared is 16. 16 plus 16 is 32. So 32 is equal to c squared. Okay. If we want to find the length of c, we would do a square root. And so we'd get that the square root of 32 is equal to the square root of c squared, which is c. Okay. Now we could continue farther and get a decimal guess for how long this is. I'm not going to take the time to do that, and the reason is because I'm thinking ahead to what I'm going to end up doing with this number on this side of the triangle. I'm going to use this number in the Pythagorean theorem again, and remember, when we substitute a number into the Pythagorean theorem, it ends up being raised to the second power anyway. And so it would be kind of unnecessary to figure out a decimal for this, only to end up squaring that number and just get 32 again. Okay? So now that we know that this distance here is the square root of 32, we can focus our attention on this right triangle, which has the letter x written on its hypotenuse. So let's do the Pythagorean theorem again. A squared plus b squared equals c squared. Okay. This leg of the triangle is the square root of 32 squared. And then this leg of the triangle with 4 on it, let's use as b. And then c, the hypotenuse of the triangle, is this side here, which has the letter x on it. So I'm going to put in x where the c is in the Pythagorean theorem. Okay. Now, the square root of 32 squared makes 32. And 4 squared is 16. And that is equal to x squared. Adding these together makes 48 is equal to x squared. To solve for x, let's do a square root. So we get the square root of 48 is equal to, and the square root of x squared is x. Okay. This time I am going to take the time to evaluate the square root of 48 because this is my answer for x, and that's the side I'm actually asked to figure out. I want to know about how much that is. Okay. 48 is not one of the perfect square numbers, so we're going to have to take a decimal guess out to the 10th position on this. Okay. Let's think about our square numbers. Okay. 6 squared is 36. And so the square root of 36 would be 6. 7 squared is 49. So the square root of 49 is 7. 48 is very close to 49. And so that means that the square root of 48 is just a little bit less than 7. How about 6.9? And so we have 6.9 centimeters is the unit of measurement that I noticed in the drawing, equals x. Now, day 3, problem 2. Part A, graph figure ABC with these vertices. -2, 2. Left 2, up 2 is right here. 3, -1. Right 3, down 1 is right here. And -3, -2. Left 3, down 2 is right here. So here is triangle ABC. Graph its reflection over the y-axis. So here's the y-axis. I'm going to highlight that in red. That is our reflection line. And we want to flip all 3 of the dots to the other side of the reflection line. Okay. So point A is 1, 2 units to the left of the line. 2 units to the right of the line would get us A prime. Point B is 1, 2, 3 units to the right of the line. 1, 2, 3 units to the left of the red line is B prime. Point C is 1, 2, 3 units to the left of the reflection line. So 1, 2, 3 units to the right of the reflection line is C prime. And we can connect these together to create our new triangle. Okay. The red triangle is the reflection image of the original black triangle. Part C, find the coordinates of that reflected image. So let's start with A prime. A prime from the origin is right 2, up 2. And now B prime. B prime from the origin, left 3, down 1. And now C prime. From the origin, it is right 3, down 2. Here are the coordinates of the reflected image.